Alright, here we go. Solving some more trig equations. This time we're going to look at some with some using some different identities and the algebraic technique of squaring both sides. Anyway, here's an example to get us started. The difference here is that I've got a 2x in here. This is 2 times the cosine of 2x minus 1 equals 0. I'm going to solve it in a similar way to, I think, the very first example we did in the first video. So add the 1 to both sides, divide by 2, cosine of 2x equals a half. By taking an inverse cosine of both sides, I can figure out what 2x is. 2x is the inverse cosine of a half. Now that's I happen to know that that's a nice angle because to get the cosine to be a half, you're doing 1, 2. Once you've got the hypotenuse of 2 on the side of 1, that's going to be a square root of 3 over there. So you're talking about a pi over 3 angle here. Or anything coterminal. So 2x here was my angle, has to equal, right, 2x was the angle inside the cosine. That's got to equal pi over 3 or anything coterminal, so plus 2 pi n. Or there's another place where the cosine could be equal to a half, and that would be down here, right? So that's minus pi over 3, or 2x equals negative pi over 3 plus 2 pi n. But if that's what 2x has to equal in order to get this cosine to equal a half, then x has to be half of that. Divide everything by 2 here. X is pi over 6 plus, and when you divide by 2, divide this by 2 as well, and this just becomes a pi n. Or here, x is minus pi over 6 plus pi n. Now, something to point out here, that this makes some sense, because if you think about what the graph of the cosine of 2x looks like, that 2 has squeezed the cosine curve by a period of by a factor of 2. So the period that was 2 pi is now pi. So for every answer you have here, adding on pi n is just moving over multiples of the period of the function that you're dealing with. Right? This will repeat twice as often as just cosine of x repeats, and hence rather than adding a 2 pi n, you end up adding just a pi n. Okay? Using double angles, if this had been a 3x in there, then I'd had a 3x here and a 3x here, and I would have divided everything by 3, and this would have looked like a 2 pi over 3 times n. Right? Whatever that number is, it just ends up here and you divide by it. Okay, that being said, my next example is the sine of x plus the cosine of x equals, let's just say 3/4. Solve for x. Solve for x. Now, we saw an example in the last video where if I had a sine squared or if I had a cosine squared, I can convert it into the other one. Well, I don't here. But what I'm going to do is I'm going to create it. I'm going to multiply, I'm going to square both sides. Now, whenever you do this, you run the risk of introducing extraneous solutions. Right? I'll show you an example here as soon as I get this written down. I'm squaring both sides. Be careful. Here's an equation, x equals 2. Right? It has one solution. I hope you can see what solution it is. I think if you let x equal maybe 2, then this will be true. But if I square both sides, I'm looking at x squared equals 4. This now has 2 solutions, right? Positive 2 or negative 2. So squaring both sides, you will find solutions originally are still solutions here, but you get extra ones. So I'm going to do this, and I'm going to go back and check and make sure my answers actually work in the original equation. Okay. So let's see. I'm going to, when I square this out, careful, it's a binomial squared, so it's a big FOIL here. So I get sine squared x plus 2 times sine x times cosine x plus cosine squared x, and this is what, 9 over 16. Okay. And the reason I did this is because I didn't want sine and cosine. They don't go together nicely. But sine squared and cosine squared do go together nicely. So in fact, what I have here is 1 plus 2 sine x cosine x equals 9 over 16. If I subtract that to the other side, so I've got 2 sine x cosine x equals 9 over 16 minus 1, which would be 9 minus 16 over 16, which is 9, I take away 16, negative 7 over 16. Okay. But I got a sine and a cosine here. But actually I have a 2 times a sine and a cosine, and all of a sudden I'm thinking, that reminds me of an identity. It reminds me of the double angle formula for sine. That this thing right here is actually the sine of 2x. This is equal to negative 7 over 16, and all of a sudden I'm feeling like, hey, I might be able to do this. So I'm thinking sine is negative 7 over 16 there, or negative 7 over 16 here. Those are the two places where I could have the sine being negative, third and fourth quadrant. That's not a particularly nice angle, so I'm going to use my calculator to find that 2x equals the sine inverse of negative 7 over 16. So I'm going to do that real quick. Sine inverse negative 7 divided by 16. And I know that the inverse sine is going to give me this angle here, because it's going to give me either a fourth quadrant or a first quadrant angle. So 2x would equal negative 0.4528. It's in radians, or anything coterminal with that. So I'm going to say plus 2 pi n. And then I got to go find this other one. Well, this other one looks like, I can divide by, that's 2x. So x, divide that by 2, is negative 0.2264 plus pi n, right? Because when I divide that by 2, the 2 pi will turn into a pi. So there's one set of solutions. I'm going to have to check them here in the end. But let's just come back here. There's another possibility, in that over here 2x might have been this angle. So that's going to be pi plus so I'm going to go through pi, and then I'm going to go through plus whatever this angle is. This is a negative angle, but I'm going to make it positive and go that way. So I get 3.5944 is that angle going around in the counterclockwise direction. Okay, and then anything coterminal, and then divide by 2. And I get 1.7972 plus, pi n. Okay. Now, I have to be real careful here because I squared both sides. So I'm going to have to check and see which one of these actually satisfy the equation. And what I'm going to do here, if I look at the sine curve and the cosine curve, oops, I started coming up too soon. Well, let me draw that cosine curve again. And I think about adding them together. Well, you add them. When you add, if either one of them is 0, then you're right smack dab on the other one. Where one of them is positive and one of them are negative, they're going to cancel out. This will be here, here, here. So this looks like this when you add them together. And what I was looking for is, where is this equal to? And I can't remember, was it 3/4? Was that what I said? Yeah, I wanted sine x plus cosine x to equal 3/4. So I'm getting places up here. Let's do this in another color here, purple. Nah, let's do in a lighter color, purple. So 3/4 is somewhere in this range. So there's spots here and here. There's also spots where it's going to equal negative 3/4. And those are the ones that are going to show up as my solutions. So I have this set and that set. Okay. The negative 0.22 is this one right here. That's the one that's closest to 0. Okay. The 1.7, sorry, when I add pi onto that, well, if I add 2 pi onto that, that's getting me clear back over to here. Adding pi onto that is getting me to this one. So that's no good. So I've got to be careful. I'm looking at this one thinking, the first one worked with n equals 0. When I add on 1 times pi, that gets me to this spot here, where this is down at negative 3/4, and I don't want that one. But adding on 2 pi was okay. So I think that although these look like they're solutions, they are solutions to the squared equation, but only half of them were solutions to the original equation. So I'm going to get rid of the other half. I realize that I can take x equal to negative 0.2264 plus, I just want to do 2 pi n. I want to skip every other one because those are the ones that are headed down low. Likewise down here, if I look at the 1.79, 1.79 is this one, right? I'm just thinking because pi over 2 is here. That's like 1.5 something. So 1.7 is just a little bigger. That's this one. When I add on pi to that, it gets me to here, and that's this negative one again. When I add on 2 pi, it gets me clear back over to here, where that line hits. It's like, all right, again, I don't want all of these. I want every other one. So what I really want is x equal 1.7972 plus 2 pi n. This was an n right there. Okay. So these are the ones that work. I needed to square it. I needed to square this equation in order to get my algebra to work for me. But when I'm done, I got to say, check them, because some of them are going to be places where you've got a solution, and some of them are going to be places where you have a solution to the squared equation, but not the original one. Okay. There you go.